Good day, everybody. My name is John Winkowski, and I am the Planetarium Coordinator for the Besser Museum. And starring with me today is our science kitty, Minerva. She's going to be helping us with our talks today about, well, our video. Today is a very auspicious day, and that is because it is the 50th anniversary of Earth Day. And for this special Earth Day video, I want to talk to you about the stars. More specifically, though, I want to talk to you about the patterns of stars that we have in the sky. Because believe it or not, the stars that we see here on Earth are unique to the entire universe, and the same patterns can't be seen anywhere else. Now, before we get into the complexities of the stars and the night sky, I want to talk to you about my second favorite topic, history. You see, the stars as we know of them in the night sky haven't always been thought of in the same way all throughout human history. Ancient cultures and civilizations had their own stories and myths surrounding the stars. Some involved magic and sorcery, others involved the gods and the deities, while others were simply just the light of heaven shining through a dome that surrounded the earth. While these mythologies are definitely fascinating, they're not very scientifically accurate. So to understand this a bit better, we have to dig into the modern science. Modern astronomy has proven that the stars we see at night are just giant balls of burning hydrogen, very similar to our sun. Except the main difference being our sun is rather close to us here on Earth, while the stars are much farther away. So far, in fact, that their light just looks like a single little point in the nighttime sky. Now, you may be thinking, that's cool and everything, but if the stars as we see them are viewed from so very far away, doesn't that mean that they can also be seen from different parts of our solar system and galaxy? And the answer to that is both yes and no, because while they can be seen, they're not going to be viewed in the same exact way. Not only will the brightness be varied depending on our distance to the stars, but also the positions of our planets, even within our own solar system, will determine what stars we see and the patterns they appear in at night. You see, these two factors are what really make our night sky unique. And to be more specific with them, that is a star's physical brightness as well as its position in the sky, which, as we mentioned, will vary from place to place and planet to planet. But let's get a little bit more specific by starting with the first of these topics, that is, its position in the sky. Let me focus on the star positions first, which come from the Earth's movement. At any given moment in time, the Earth is moving in multiple different ways through our solar system. And we're not going to get into this today, those movements of our planet. That's going to be a topic for another video in the future. But for now, I just want to let you know that these movements are essentially going to be pointing the planet, and thus your position on the planet, towards different parts of the universe. Which means that the stars that you see at night are going to vary depending on these planetary movements. And as you may have guessed, not every planet moves exactly the same way. For instance, if you were to teleport to Mars tonight, heading to the exact latitude and longitude as you were on Earth, and then look up at the Martian night sky, the stars that you would see would be a little bit different. For instance, let's say that tonight Orion, the constellation, would be high and bright in the southern part of our sky here on Earth. Well, on Mars, that constellation may be in a completely different location, or maybe not visible at all. And other constellations that would normally be below the horizon would be high up above the horizon on Mars, including some southern constellations that are only visible in Earth's southern hemisphere. And that's just due to Mars's different orientation into space. It's not wrong, it's just different to what we have here on Earth. While the Earth's positioning and movements are unique in our solar system, it's definitely plausible that there's an exoplanet, a planet outside of our solar system orbiting another star, could have the same exact types of movements that Earth does. And this brings us to the second distinction for our topics today, that being a star's physical brightness. Stars, while bright, aren't going to be viewed the exact same way everywhere in the universe. And this is due to the fact that the closer you are to a star, the brighter it will be, and vice versa as you get farther away from the stars. In the scientific community, we call this absolute and apparent magnitude, where the magnitude can be thought of as a measurement of a star's brightness. And it simply tells us that the closer we are to this bright object, the brighter it will be. And anybody who's ever had a flashlight shone directly into their eyes before can attest to this fact. The differences between absolute and apparent magnitude are where you're measuring the star's brightness from. Apparent magnitude is what we use to measure a star's brightness from here on the surface of the Earth, while absolute magnitude decides to take a bit more of a scientific approach by calculating how bright every star would be from 10 parsecs or 32.6 light years away from that star. Essentially, apparent magnitude is just how a star looks to us here on the surface of the Earth, while absolute magnitude measures all the stars from a fixed distance. That way we can get a better, more accurate representation of that star's actual magnitude. How this relates to Earth's night sky is pretty simple. For instance, if we were to make an exact copy of our solar system and plop it down on the opposite side of our galaxy, we notice that the sky is a lot different right away. This is because while stars are bright, large, and can be seen from many light years away, there are limits to what the human eyes can see. And in fact, every star that makes up our night sky is only within a small distance from our sun. At its furthest, the human eye can only see stars about 10,000 light years away from us, which may sound incredibly far away until you look at it from a galactic perspective. This picture on screen right now is a representation of our line of sight in the Milky Way galaxy. This small sphere, that is the entire limit of our sight without telescopes or optics of any sort, which you can see is a rather small portion of our galaxy, which actually measures about 100,000 light years across. While it may seem incredible that our view of the sky only captures this small portion of our own galaxy, things actually get even crazier from there. This picture we're looking at now is called the Hubble Deep Field, and it is a picture of one of the darkest, most unremarkable parts of our night sky. However, using the Hubble telescope's remarkable technology, astronomers were able to bring into focus thousands of tiny points of light, with nearly every one of them being an entirely separate galaxy from our own. If you thought it was remarkable that there's a place in our galaxy where all of Earth's nighttime stars were no longer visible, you'll be amazed to realize that there's a place in the universe where our entire galaxy, the Milky Way, is also invisible. And this picture is proof of that. A spot in our galaxy that is empty of light was revealed to be filled with galaxies just as big and even bigger than our own. We're talking about trillions of stars and planets that are completely invisible to the human eye. And this brings us back to our original point, that the night sky that we see here on Earth is unique. Because as we learned today, there isn't another celestial body in all of our solar system that will see the stars in the same patterns that we do here on Earth. And we also learned that the stars, while bright, can only be seen from a certain distance. And there's plenty of places, not only in our galaxy, but the universe, where we'll see completely different stars than our own. The universe may be big and incredibly overwhelming to think about. However, our place in it is certainly unique. Alright, that's pretty much going to be our video for today. Me and Minerva both wish you a happy 50th birthday. Goodbye.